Hello, today we'll take a look at solving application problems that lead to quadratic equations. We're going to look at a variety of different types of problems, starting off with what I refer to as the translating problems, where you're literally translating English words into math symbols. Then we'll get into projectile motion, geometric, distance, and we'll end with working problems. So when you're first given a problem, you want to look for keywords that will help you determine what kind of problem it is. Here we have consecutive odd integers, things like 1, 3, 5, 7, 9, and so on. Notice that each of the odd integers is 2 units away from the one in front of it, consecutive. Now, they want us to represent 3 of these, so we always begin by letting the first one be x. The next odd integer will be 2 units away from that, so x plus 2. The next odd integer will be 2 units away from that, so x plus 4. So we have the 3 represented. Let's read on to see what they want us to do with it. It says here that we have them in such a way that the square of the third one, well, here's the third one, is 15 more than the sum of the squares of the first 2. So we know that squaring something means raising it to the second power. So we're going to have the square of the third is, remember, stands for equal. 15 more than, so that means we're going to be adding 15 to the sum. Well, sum means addition, so we're going to be adding 15 to the sum of the squares of the first 2. So we're going to be squaring each of these. Our equation will look like this. Now realize it may take reading through this a couple of times in order to piece the puzzle together. So once again, we have the square of the third is 15 more than the sum of the squares of the first 2. So here's our equation that we're going to now solve. To solve this, you would FOIL this out, x plus 4 times x plus 4. This will be x plus 2 times x plus 2. And when you finish foiling it all out, you're going to end up with a quadratic equation that you then solve. And remember, quadratics usually generate at least 2 answers, usually. Sometimes we end up with 1. So foiling everything out, combining like terms, putting it into quadratic form, this is what we end up with. You can then choose at this point to factor it or use the quadratic formula. I chose to factor, and I ended up with 2 possible answers for x. We ended up with x being equal to 3 and x being equal to 1. So remember, we were asked to turn in 3 consecutive odd numbers. So if x equals 3 is my first odd number, the next odd number after that will be x plus 2, so 3 plus 2, and then the one after that will be 3 plus 4. So notice here are the 3 consecutive odd numbers I could turn in. However, if we let x be 1, which was the other possible solution, then my 3 consecutive odds would be 1, 3, and 5. So you have 2 solution sets to turn in for this particular problem. Our next example is a projectile motion problem. Notice here a toy rocket is launched. We're giving an equation representing the height after t seconds. The question then is, how long will it take for the rocket to hit the ground? Well, think about, what would the height be of the rocket when it's on the ground? The height would be 0. So what we're going to do is take the equation they've given us and set it equal to 0. We're then going to solve. Notice it's a quadratic equation. So we could use the quadratic equation to solve it. Once it's in quadratic form, which it is, we identify what a, b, and c are. I like to go ahead and find the discriminant. So plugging in b squared minus 4 times a times c, I found the discriminant to be 412.09. I then plug everything else into the equation. Remember, we are looking for t actually, so time. All right, so negative b plus or minus the square root of the discriminant, which we found, divided by 2 times a. Simplifying this using the calculator, And then separating this so that we could simplify it even further, we have negative 18 plus 20.3 divided by negative 9.8. And then we have the other one, which is negative 18.9 minus 20.3 divided by negative 9.8. Plugging all of this into the calculator, these are the two solutions we came up with. Now remember, we were looking for the time that this would take to land on the ground. Since time cannot be negative, our final answer will be 4 seconds to turn in. The next problem we look at is a geometric type problem. As you read through, you realize we're dealing with a geometric shape, and so it's very helpful to go ahead and draw a picture of what you're dealing with. Draw a rectangle. Now let's see if we can label the rectangle based on the information they've provided. It says the length is 1 inch less than twice the width. Now we don't know what either measurement is, but what we'll go ahead and do is start off by labeling the width W because they are describing the length in terms of it. Alright, so we'll label the width W. The length then, as it says, is 1 inch less, so subtraction, than twice the width. So 2W minus 1 for the length. It then goes on to say the diagonal, which is the distance across the rectangular, from one corner to the other. It says if the diagonal is 2 inches more than the length, so that means addition, 2 inches more. Well, we have the length represented as this, so if we add 2 to that, then our diagonal would end up being 2W minus 1 plus 2, or you could just say 2W plus 1 if you want to simplify it. It then says find the dimensions. So here we have these different parts labeled on our rectangle. How can we use it? How can we put it together in an equation? Well, we can use what we refer to as the Pythagorean theorem because we know that the angles of a rectangle are all 90 degrees, and so we have the two sides of a right triangle and the hypotenuse identified here. So what we're going to do is take those two sides, so W squared plus 2W minus 1 squared, and set it equal to the hypotenuse, or the diagonal, squared. All right, simplifying that diagonal, as I said, getting plus 1 there, foiling this out and foiling this out, we're going to again end up with a quadratic equation. As we said, this whole section is going to generate quadratic equations. So simplifying everything, combining like terms, this is the quadratic we end up with. The easiest way to solve this would be by factoring. So we factor out a GCF of W. We then set each part to 0, and we end up with two possible answers, 0 or 8. But we have to remember what was W standing for. It was the width of our rectangle, and the width cannot be 0, otherwise we would not have a rectangle. So our final answer to turn in would be a width of 8, and then the length would be twice that minus 1, so 15 inches. The next problem we're going to take a look at involves distance, and we are familiar with the distance formula as D equals R times T. As you read through the problem, usually in any distance problem there's going to be at least two things involved, whether it's two modes of transportation or two parts of the trip where they are going and returning, or two different people involved in the trip. There's usually two parts to the problem. And so I like to organize the details of our distance problem in a chart. Now, in the previous lessons in this chapter, we dealt with distance problems where they were giving us R and T, and then we set everything equal to D. In this particular problem, we're going to notice that they actually gave us the distance. We have some information about the rate, and what we are doing is solving for T. And so what we had to do here is take the distance formula that we're used to, D equals RT, and we had to solve it for time. So to do that, what you would do is divide both sides by R, and you would end up with what we have here. Time is equal to distance divided by R. And so I started off labeling the two parts of my trip, and then I labeled the distance in the chart, then the rate, and we put time at the end. So it goes on to say that this car traveled 280 miles, averaging a certain speed. If the car had gone 5 miles per hour faster, so the two things in this trip are first scenario and then second one, driving faster, okay? The trip would have taken 1 hour less time if they had driven faster, which makes sense, right? This time over here would be less, this over here would be more, and the difference between the two would be 1 hour. Find the average speed. Now, we had the distance on both scenarios as 280. The speed is what was different. At one point they were going X, and then at another point they were going 5 miles per hour faster, so X plus 5. To get time going across here, we're not multiplying, remember, instead we are dividing. So distance divided by rate equals the time the first trip would have taken, which we realized would be more because they were driving slower. Then the second possible scenario of the trip, we take distance divided by time, and we know that this is going to be a little less time because they were driving faster. And the relationship between these is there's a difference of 1 hour. So we take the more time from the first scenario minus the less amount of time from the second, and that would equal a difference of 1. So here's our equation that we need to solve. Now you may say, well, that doesn't look quadratic. Right now it does not, but as we solve, we're going to see it leads to a quadratic. So what we notice here is it's an equation that has fractions in it. So we want to get rid of those fractions, and we do so by multiplying by the LCD, which in this case will be x times x plus 5. So we multiply everything in the equation by that. Well, here the x's cancel, here the x plus 5's cancel, here nothing cancels. We have to multiply the 1 times that. And so we end up with this, an equation with no fractions in it. Using the distributive property, combining like terms, we end up with this quadratic equation, which we now need to solve. All right, solving that, we chose to use the factoring technique, and so factoring it, we ended up with 2 possible answers. Now looking back at what x was representing, it was the speed. Can we have a negative speed? No. So we throw that answer out. It cannot apply to this particular problem as a legitimate answer. And so we end up with the speed being 35 on the first scenario. And then if they wanted to know what the other one was, on the second scenario, we would say 35 plus 5, which is 40. But they just wanted the 35 this time. Our next example is what we refer to as a working together problem. You've seen these in the previous lesson as well, where you have 2 people or machines working together to complete a job. To set these up, I like to actually set up a fraction where I show the effort of one person or machine plus the effort of another equal 1 job done. On the top of both fractions, you put the time it takes them working together. On the bottom of the first one, you put the first person's rate or machine's rate, and then at the bottom of the next fraction, you put the second person or machine's rate. All right, so reading through, we see we have 2 people, Jeff and Kurt. Together, they could complete this job in 12 hours, so notice we put time together on top. Because Jeff has more experience, he could build the wall 4 hours quicker than Kurt. We don't know either person's speed, but we have a description now. So what we could do is label Kurt as X because they describe Jeff in terms of Kurt. And then we could label Jeff as X minus 4 because again, his time would be 4 hours quicker. He needs 4 hours less time than what Kurt would have needed. All right, question, how long will it take Kurt to the nearest minute to build the wall by himself? So we're looking for the X. All right, so now we have an equation that has fractions in it. We need to get rid of those fractions, and so to do so, we use the LCD again, which is x times x minus 4. When we multiply everything in the equation by that, over here the x minus 4's would cancel, and you'd get this. Here the x's would cancel. Here nothing cancels, and you have this. So you have your equation now with no fractions. Using the distributive property, combining like terms, we end up with a quadratic, which we expected. I would first try to factor it, but once you see it's not factoring, see I listed my different possible combinations of 48 and nothing was giving me 28. So what I then did was go ahead and use the quadratic formula. Identifying A, B, and C, we plug everything in, and this is what we end up with, 28 plus this or 28 minus this. Typing this into the calculator, these are the 2 answers I ended up with. Well, if we recall, we were looking for X, which was Kurt's rate. Well, an answer of 1 hour would then mean that Jeff was 1 minus 4, which would be negative, and that's not possible. So we're going to go with the 26 hours for Kurt. To convert the hours into minutes, we subtract 26 on our calculator and then multiply this decimal portion times 60, and that lets us know it's 9.93 minutes. They wanted you to round to the nearest minute, so 10 minutes. That completes this section.